Suppose we have this rectangle with length 4 units. We inscribed a semicircle inside and also a quarter circle as shown. Can you solve for the shaded area? Let's begin. Let small r be the radius of the semicircle and capital R be the radius of the quarter circle. The opposite sides of a rectangle are equal. Hence, capital R is equal to 2 times small r. Next, draw a line that connects the centers of the semicircle and quarter circle. That segment consists of small r and capital R. Now, we have formed a right triangle with hypotenuse of small r plus capital R and legs of small r and 4. Applying the Pythagorean theorem on the right triangle, we get 4 squared plus small r squared is equal to small r plus capital R all squared. 4 squared is 16. And then let's substitute capital R equals 2 times small r into the equation. Let's proceed. Small r plus 2 times small r is 3 times small r. 3 times small r squared is equal to 9 times small r squared. Transpose r squared to the right side. We get 16 equals 9r squared minus r squared. 9r squared minus r squared is 8r squared. Divide both sides by 8. To get r squared equals 2. Next, let's say the area of the semicircle is A1. The area of the semicircle is half of the area of the circle of same radius. Therefore, A1 is equal to 1/2 pi times small r squared. Now, let's assume that the area of the quarter circle is A2. The area of a quarter circle is 1/4 of the area of the circle of same radius. Therefore, A2 is equal to 1/4 pi times capital R squared. Substitute capital R equals 2 times small r into the equation. This is 4r squared. And 1/4 times 4 is 1. So this becomes pi times small r squared. Now the area of the shaded region is just the sum of the areas. So let's add the 2 area expressions. One half plus 1 is 3/2. So we get 3/2 times pi times small r squared. Finally, let's substitute small r squared equals 2 and cancel out the value 2. The area of the shaded region is 3 pi square units. Thanks for watching. Please subscribe to my channel for more engaging math puzzles.